Exam 1 review. This is, I believe, a past exam problem, and it's one of the more difficult ones that you will see on an exam, so it's very good practice. So this question says, determine the moment of the force F about point O, and then the second part, also determine the magnitude of the moment about the axis OA. So I'm going to break it down. This first part, we're just going to try to find the moment of that F causes about point O. So the nice thing here is they've already given you F in magnitude and in vector form, so you don't have to fool around to find the vector form. So for the first part, you always need to make sure that you label your R vector, or your position vector, from point O to the line of action, to the force. Because then the first part is pretty simple. We know that the moment is R cross F, so they've already given us F. All we have to do is find R in vector form. And that's pretty simple as well. So we just need to find this point here about the origin. So it's 6 in the positive x direction, 8 plus 6, 14 in the positive y direction, and 10 in the positive z direction, or positive, z direction. And pay attention to units. We are working in pounds and inches here. So now that we know our force vector, our position vector, all we do is do R cross F. We do the cross product. I hope you guys know how to do that. And you end up with 3 different components. You have an x, a y, and a z component. And you need to make sure that you're expressing this in vector form, because when you do R cross F, you always end up with a vector. Now, previously you've only ended up with a vector with the k component, but now we have all 3 components. And also make sure you put in your units there. A moment is pound times inches, or force times distance. So our first part that was pretty simple in my opinion. Then we move on to the second part, where they ask for the magnitude of the moment about the axis OA. Now, you did a similar problem like this in class, but it asked for the magnitude of the projection of the force. So it's pretty much the same calculation. They're looking for the magnitude of the moment OA. So all you have to do is take the moment that you solved in the first part, the moment about O, and dot product with the unit vector OA. So we have MO, now we just have to find the unit vector OA, which is also quite simple. So we just find the position vector from O to point A, and that's 6 in the positive x, 8 in the positive y, and 0 in the positive z direction. So that gives us 6i plus 8j inches. Then we take the magnitude via the distance formula, so it's 6 squared plus 8 squared, that gives us 10 inches. And the unit vector is just the position vector over the magnitude of the position vector. So our unit vector ends up being 6/10 plus 8/10, and then you simplify it and you get this. So this is your final unit vector. So now that we have the unit vector, all we have to do is unit vector dot moment vector about point O, and we have both of those at this point, and you should probably know how to do dot products at this point. So do the dot product, and we end up with the magnitude of the moment OA is 190.76 pounds per inch. So that's pretty straightforward. Some tips that a lot of you guys have been making mistakes on quizzes is negative or positive components. Now in this problem they're all positive x, positive y, positive z, but in other problems you have negative components. A y component could be going downward, so that means it's negative. Pay attention to that, because most of you have been messing up on that. Also, labeling your diagrams. So here they already labeled F for you, but whenever you're talking about an R vector, a position vector, from O to A or from O to your force, you need to label it on the diagram. Another important thing where points come off, units. Make sure, is it pound times inch? Is it newtons times meters? You always need to include the units. Also, magnitude versus vector. Are they looking for the magnitude of the moment, Or are they looking for the actual vector of the moment? Because that's going to have the components. I, j, k. That's a vector. This is going to be a scalar. Once again, the same thing. If you take a dot product, the dot product is going to give you the scalar. If you do a cross product, you're always going to get a vector. So those are very important things and like subtle details that you need to make sure you're paying attention to. On the exam, points will be taken off for these things.